Let us continue with machine learning. And we are looking into the topic analogy. So the dictionary meaning of the term analogy means showing how two things are alike. It's a comparison between two things, and we are saying they are equal by seeing some properties or something like that. So purpose of analogy is not merely to show but also to explain. The similarity is not just to show that they are similar, but we will be using that similarity of these two objects for explaining how they became similar. For this reason, analogy is more complex or more definite than a simile or a metaphor. If we are saying without explaining that A is like B or A is same as B, but no explanation is given on the similarity, then we can say that it is a metaphor or simile, because they are both same. We are without explaining saying that A and B are same. But this is not the case with analogy. We have to explain that how they became similar on viewing some similarity. So that is the dictionary meaning of the word. It means comparing one thing to another for the purpose of explanation or clarification. The best example can be analogy between herd and a pump, because both these objects, our herd as well as a pump, is used for their functions are same for taking some quantity of liquid from one portion to another. So both of them are similar, and we can explain that using their functions. So let us see how this concept can be used in our machine learning area. So with learning, it's a powerful inference tool. Analogy is a powerful inference tool in learning. It involves abstracting details from a particular set of problems and resolving structural similarities between previously distinct problems. We will be having some problems previously defined and found their solutions, and that can be used for solving new problems. For that, what should we do? We have to prove that these two are similar. The problem that we have already solved is similar to the problem is to be solved currently. If they have, those two problems have similarities, the steps that we have taken for solving the previous problem can be applied in the new problem also. In that case, we will be using this analogy form of learn. Analogical reasoning refers to this process of recognition and then applying the solution from the known problem to new problem. So this process, that is, first we have to find a similar problem that we have solved already, and we have to apply the steps that have been used for solving that problem to the new problem. This process is known as analogical reasoning. It involves developing a set of mappings between features of two instances. So we are mapping two instances for this purpose. It may not be a one-to-one mapping, because some differences may occur between these two problems, but they may be almost similar. Then the solution that we have found can be applied. By making slight changes, we can find the solution for the new problem also. Then we will be using analogy type of learning. Then analogical reasoning is also known as argument by analogy, and the definition goes like this. It's a specific way of thinking based on the idea that because two or more things are similar in some respect, they are probably also similar in some further respect. So we are assuming that if we found some similarity between two things by considering some aspects, then we are assuming that those two things will be similar if we consider some other aspects as well. This is known as analogical reasoning. With some similarity, by considering some aspects, we found some similarity. The same similarity can be found out if we consider other aspects also. That is the assumption made in analogical reasoning. The steps involved in analogical reasoning are: one is retrieve. We have to retrieve cases from memory that are relevant in solving. If there are previously solved solution available in the memory, we have to retrieve that which is close to the problem that we are having now. So that retrieval is the first step. Then we have to reuse. Once we retrieve some information, we have to use that information. Why we are saying reusing? Because it is already used in the previous problem. So we will be mapping the problem from previous case to the target problem, which is the current problem. It involves adapting the solution to fit new solution. So we have to fit the previous solution to the current solution. For that, mapping is required or reusing is required. Then, as I said, the two problems may not be having a one-to-one correspondence or mapping. So we may have to change some of the facts that have been retrieved. For that, we will be using revision. We have to revise, test the new solution to real world, and if necessary, we have to change some facts that have been retrieved. So we have to revise that. First we will be retrieving, then reusing, then revising. And if found everything okay after revision and all, we are able to solve the new problem, we have to retain those facts. So we got some new facts from this revision or with the previous three steps. Then we have to retain that for future usage. So after successfully adapting the solution to target problem or the current problem, store the resulting experience. What we have gathered at present becomes a new knowledge, so it becomes an experience. It has to be stored in the memory as a new case, and this can be used for similar problems which is arriving at a later stage. So this is the analogical reasoning steps. And then there are two types of analogies present. One is the transformational analogy and the other is derivational analogy. Let us see the first one, transformational analogy. Here the problem solving technique in which a pre-selected plan is modified to solve a new problem. We have already said that from the previous problem solutions which are compared with the new problem which is in our hand, and if we find some similarities between those two, then we have to select that solution and apply it to the current problem. So problem solving technique in which a pre-selected plan, so we are selecting already solved process and it is modified to solve a new problem, because we are not having a one-to-one exact similarity will not be there, then the problem becomes same. So exact similarity will not be available, so we may have to make some modification to the previously selected solution, and we are applying that to the new problem solving method. For that we will be looking for a similar solution that corresponds to the current problem. Then we are copying to the new situation. to the new space, we are copying the solution or methods that are used for solving the previous problem. Then we are making some suitable substitutions or changes wherever applicable for finding the new solution. So this is the form or methods that are followed in transformational analogy. So this is possible. This modification or changes are possible by using these steps. One is removing unwanted steps from the previous plan or previous solution. We will be removing unwanted steps from previous solution, and we may have to add new steps as well to the previous solution. Then sometimes we may not be required to remove the steps. We may have to change the parameters of the steps or procedures that are followed in the previous solution. But if we are changing those, we have to bind, or we have to stick on to the constraints that are available with the problem space. We have to follow the constraints or conditions that are, or we should not change this. Within that limit, we can change the parameters of the steps in the procedures. And then we can add or remove or reorder the conditions that are used in the plan. By using these modifications, we can adapt to the new solution of a problem. This can be represented as a figure. So we are having a previously solved problem which is almost similar to our new problem. This is our new problem, and which is almost similar, not exactly the same. So it is having a partial mapping between these two. They are almost similar, and by following some steps we are able to find the solution to the old problem. And if we follow the similar steps with some changes, like we have discussed earlier, by some changes we will be able to find a solution. And this is known as the transformation process from this solution to this solution. The solution is being transformed into a new form by making some changes in the steps that are used here. So that form of analogy is known as transformational analogy. Then let us go to the second type of analogy, which is derivational analogy. It is slightly different from the transformational analogy. It stores the problem solving decisions and their justifications in the source plan and replays them for the target. Here again we will be considering a similar problem that have already been solved, and we will be taking those steps that are being used for solving that problem, and we will be checking all the steps that are used in the previous problem for justifying the generation of the intermediate results in that problem, and those steps will be clearly studied or investigated for generating some intermediate steps in the new environment. That is, given a planning problem and a solution plan to a previous problem, a derivational plan looks at the history of the problem solution. So it will be looking into all the steps that are being used for the previous problem. In the transformational track, we will not be looking into the steps that are being used thoroughly, because we are transforming the solution to the new format by making some intermediate changes. Here it is not the case. We have to look for the history of the problem solution and the steps involved and the decision taken at every stage that led into those steps being added into the solution plan. We will be checking thoroughly each and every steps that have been used in the previous problem and how they are generated to form the next steps in the previous problem will be taken into consideration, and that change is being used for this problem also, for the new problem also. So here we are deriving some from the previous statements that are or procedures that are being used in the same way that have been used in the previous problem. So derivational analogy makes use of this information to arrive at a solution for the current planning problem. This will be clear if we look into the picture. Here we don't have a solution of old problem which is being transformed into the new form. It is not being considered here. We will be looking into these patterns and how they became from 1 to 2, from 2 to 3, if there are so many processes being involved in finding the solution to the previous problem, how they are being converted from one procedure to the from one action to the next action is being considered, and the same thing is being replicated in this process also, and finally we will be reaching into the solution. Here also we will be considering similar problems which will not be having a one-to-one correspondence. So we are having partial mapping between these two, and we will be studying the patterns that have been followed in reaching the solution, and that pattern is being used here also to reach a solution. So this transformation is not there. We are deriving from first process that is being used into the second, then to the third. Likewise, we will be deriving to form the solution to the new problem. So this is what analogy says in the case of machine learning.